In this video, we are going to see about confusion matrix. Before going to confusion matrix, we'll see about machine learning. Why? Because confusion matrix is a sub concept inside machine learning. So before going to confusion matrix, we'll see what is machine learning and we'll see about confusion matrix. So machine learning is a branch of artificial intelligence that allows computer to learn from data. Instead of giving step-by-step rules, provide data and the system learn pattern and make decision. Just like human learn from experience, machine learn from examples. If we give past data and correct answer, the computer can find patterns and use them to solve new problems. Giving sales data and actual sales, that is past sales data and actual sales, if we give, it can predict the future sales. That is a good example for machine learning. So machine learning teaching a computer to learn from data and make decision, or we can say prediction, without being told exact rules. That is what machine learning. And again, machine learning is subdivided into three: supervised learning, unsupervised learning, reinforcement learning. When you say about supervised learning, system being trained with labeled data. As I said, an example, giving a past sales, current sales, it will predict the future sales. When we talk about unsupervised learning, it is unlabeled data. It will find out the hidden patterns, that is grouping the customers based on their buying behavior. Likewise, reinforcement learning, learn by trial and error. That is a good example for three types. Again, this supervised learning is divided into classification and prediction, or we can say regression. Unsupervised learning is divided into cluster. So what is classification and prediction? Classification and prediction in data mining. Prediction forecast an unknown or continuous numerical value, such as predicting stock price or house price or a temperature. This is what prediction. When we talk about classification, deals with discrete categories. So model gives us a specific label. Uh, it organizes the data into distinct categories or classes based on special characteristics, or we can say attributes. For example, we can say eligibility for loan or not eligible for loan. Even we can mark emails as spam mail or it is not a spam mail. So this is what regression and classification are the two types in supervised learning. When we talk about classification, again it is subdivided on what base it has been classified. As I said, it is classified on basis of certain characteristics, specific characteristics or attributes. So here it has been classified into binary classification, multi-class classification, and multi-label classification. When you say the word binary, the binary denotes two. That is, it is to sort the data into two distinct categories. As an example, I have given either spam or not spam. So it only chooses between these two options. When we talk about multi-class classification, the data need to be sorted into more than two categories. For example, um, the system will recognize sort of pictures of animals, which is categorized into dog, cat, or bird. When the features of the picture, like shape, color, texture, will be fed into the computer. When an animal image is being displayed, the machine will predict based on these characteristics, and it is been trained to classified on based on this characteristics what is given as an input to the system. And when I talk about multi-label classification, each instance has a multiple classes. Again, the classification will be based on any algorithm, what has been mentioned here: algorithm, logistic regression, decision tree, random forest, navy Bayes, support vector mission, and neural networks. In forthcoming videos, we'll see in detail about these algorithms. So classification will be based on these algorithm. Coming back to the exact concept of confusion matrix. So confusion matrix is to measure, used to solve classification problem. To say in simple words, the table is used to describe the performance of classification model. What it will do is it will have compare the actual value, that is what the data set is being collected with the predicted value from which the data is predicted using the models. So this is what confusion matrix. So confusion matrix will check whether the algorithm performance is good or bad. In simple words, to say whether it has been identified the correct cases or it is misclassified cases it has been identified. Let us see how the values are placed in confusion matrix. Here, confusion matrix will have two values, true and false. So, for these two values, we will have four outcomes. The four outcomes I have mentioned here, true positive, true negative, false positive, false negative. Let me explain how it has been placed in the form of matrix. Here you can see actual value, predicted value. Actual value is the values that are collected from the data set. Predicted values are from the models using machine language. So actual value will have true false, the predicted value will have true false. When actual value is true and the predicted value is also true, it is said to be true positive. When actual value is false, the predicted value is true, it is said to be false positive. When the actual value is true and predicted value is false, it is false negative. When the actual value is false and again predicted value is false, it is true negative. Let me explain with one example. We'll take a hypothetical scenario. That's we need to predict whether the patient is having a heart disease or the patient is not having heart disease. Let us have that binary classification. So for these two values, patient having heart disease, not having heart disease, for these two values, we'll have four outcomes. The four outcomes are patient who have heart disease is rightly predicted by the doctor. The patient who does not have heart disease is rightly predicted by the doctor. The patient who has heart disease but classified as not having heart disease. Patient who has not have heart disease but classified as having heart disease. Let me show these four outcomes in the matrix form, then it will be easier for you to understand. I'm going to relate this true positive, true negative. Here, when actual value is true and the predicted value is true, it is said to be true positive that we have seen. So the patient who has heart disease, it is an actual value. It's rightly predicted by the doctor from the model. So both are true, so it is true positive. Same way it continues with other four outcomes. Now let us see the matrix. So here I have shown again within a matrix the green color, which shows in green color, both are true by the uh, data set and also by the predicted value. And the red color, which shows the actual value shows negative and predicted value shows positive, that is false positive. The actual value shows negative, the predicted value shows negative, so false negative. So this is what the matrix. Now I'm going to place that scenario in this table. So the actual value, we have two values having heart disease, without heart disease. Predicted value also we having heart disease, without heart disease. In this matrix you can see here it shows the patient who has heart disease, that is from predicted actual value, and it is rightly predicted by the doctor. Here also the predicted value shows it is having heart disease. So this is true positive. Here the patient is not having heart disease from the actual value. The same is predicted by the model. So it is true negative. Same way the other two outcomes been placed here. So the total matrix it will be like this. So true positive, false negative, true negative. So this is the consultation of confusion matrix. So true positive where the patient have heart disease and predicted by the doctor. False positive does not have heart disease. The model is also predicted as does not have heart disease. False negative, patient who has not have heart disease and it is also predicted as classified as having heart disease. True negative, patient who has heart disease but classified as not having heart disease. So better to keep easily in mind for this matrix, what we can do is first we can see actual values. I'll show the previous slide. Here you can see actual value we can take. This is true, this is false. Predicted value, this is true, this is false. We can have true positive, true negative as when actual value is true, when predicted value is true, you can say true positive. When actual value is false, predicted value is true, you can say it is false positive. Why it is false positive? Not having heart disease and predicted as having heart disease. So this is false negative when it is the patient is having heart disease and it is classified as not having. So it is false negative. When actual value is also negative, predicted value is positive, it is true negative. Here, the data set has been collected from 165 and the values are given here, the actual values and the predicted values. So 50, 10 as an example values I have taken. So here true positive is 50, false positive is 10, false negative is 5, true negative is 100. So when you say predicted value, yes, it is 60. When you say predicted value, no, it is 105. But actually, the predicted value yes is 55 when compared to predicted value yes, 5 holds the difference. And when you say actual value no, it is 110 compared with predicted value is 105. So the 5 difference shows in both the values. Now we'll calculate this. So we have a classification matrix to see how these values have been given. We have a 4 metrics, that is accuracy, precision, recall, and F1 score. When you talk about accuracy, where all the predictions what is being done are correct, and precision what you say the positive, actually what is the predicted positive instant, that is true positive, false positive. So you need to see the predicted proportion of the uh, positive instance. And recall means the positive instance that the model correctly identified how many positive values are there, how this model is being identified correctly. And the last F1 score is harmonic mean of precision and recall, providing a balance measure, that is balance measure for this matrix. So I'll calculate and show with this formula. So the accuracy value, when I place the values according to the formula, the accuracy is 91 percentage, precision is 83 percentage, recall is 91 percentage, F1 score is 87 percentage. So the given classification matrix shows how well the model performs. Here in this slide, the accuracy of 91 percentage means that model predicts correctly most of the time. The precision of 83 percentage indicates that when the model predicts positive cases, it is correct 83 percentage of time. The recall of 91 percentage shows that the model successfully identified 91 percentage of all actual positive cases. So finally, F1 score of 87 percentage is a balance both precision and recall, showing that the model performs reliably by not only making accurate positive prediction but also capturing most of the true positives. So this is about confusion matrix.